Right, first problem from last weekly contest, sort matrix by diagonals. We are given a n cross n square matrix with integers grid, and we want to sort it, actually sort the diagonals, and we want to sort it in certain order. So basically, if we have something like this, if this is a matrix, then the middle diagonal and all the diagonals below it should be sorted in descending order, and the ones above should be sorted in ascending order, right? But we need to know certain traversal algorithm or certain traversal technique so that we can traverse through all the diagonals, right? So every diagonal this way from the negative side with a negative slope is going to have something constant in terms of ing, either any kind of operation. We need to experiment and see if we are able to find that pattern. If we do that, we see that I minus j is equal to k. It's a constant for every diagonal. This k can be different for every diagonal, but it's a constant. And that also we will see that for these there's a certain k, and for these there's a certain k. Right? Let's see if I have something like this as a matrix. Right? This is n cross n. We have this as 0, 0, 0, 1. These are the I and jth index. And if we try to get the I minus j thing, that will be 0 here, that will be 0 here, 0 here, 0 here, and 0 here, right? What about this one? This will be negative 1. Even this will be negative 1, negative 1, negative 1, right? So the diagonal above the middle diagonal are giving me negative constants for every diagonal. So this will be negative 2, negative 3, right? Negative 4. Wait a second, did I miss anything? Negative 2, this will be negative 2, this will be negative 2. Sorry. This will be negative 3, and so on and so forth. This will be negative 4. But here, if we do this one, finally, this will be positive 1, positive 1, positive 1, positive 1, right? And so on and so forth. We get the idea now. What we can do is we can have different techniques. What I'm going to do is I'm going to have a map, and I'm going to traverse in the you know uh, in the normal order that we always do, and for every element I'm going to push it in a priority queue. So for every diagonal I'm going to have a priority queue, right? And that map can be based on I minus j, right? So if I minus j is 0 or positive, then I'm going to push it in a max heap because I want it in descending order. Otherwise, I'll push it in a min heap, right? So I can have a map, and that will be int comma. This will be suppose a priority queue max heap. Prior queue. This is max heap. Let me call it max heap map. Similarly, I will have a min heap. All right. At this point, let me get the grid dot size, and let me traverse in the normal order that we always do. If I minus j is less than or equal or greater than equal to 0, this means that we are somewhere between, below the middle diagonal, or at the middle diagonal, sorry, on the middle diagonal, or below the middle diagonal. That's where we are at. So we are going to push it in a heap, and that should be in descending order. So it's a max heap. So it should be a max heap. So I'll take the max heap map, get the correct heap, and push it. Push what? Push the value, and do the same thing otherwise. Let me make it more concise. Okay, let me take this. This time it should be a min heap. Sorry, it should be a min heap. Alright, finally I can update the same grid, so I don't need to have any extra space. Do the normal traversal, check which heap we need to pop. This time let me have a separate block. Alright, let me remove this, get the top of the element from the max heap, and update grid of I and j with this, and also let's not forget to pop this. And finally let's do a similar thing here with the min heap. Straightforward. Let's return the grid. Let's run it. Time complexity will be O of well, equivalent to something like, in a heap we are going to push at most n square by 2 elements. So it's something around, for every n square element we are going to have a push and pop in the min or max heap. So it's going to be n square again. In worst case, something around this. So it's going to be n square log n kind of time complex, since this is a log, which is fine for this particular problem because we have n as small as 10. So that's fine. Let's submit it. Space complexity will be O of n square since we have a heap. That's the first problem. Moving to the second problem, assign elements to groups with constraints. We are given an integer array groups which is representing some value inside the group, and we are given another array elements, and we're tasked is to assign one element to each group based on the following rules. Element j can be assigned to a group I if group I is divisible by elements j. So simple. There can be multiple elements that can be assigned to a particular group, but we need to particularly take the smallest index j and assign that. Okay. So if no element satisfies the condition for a group, assign -1 to the group. That's fine. Return an array assigned where assigned I is the index of the element chosen. So on and so forth. We get the idea. Let's move to the example. Suppose we are given this as an example. At this point, in this uh, group, this is basically group, and the elements array will be 4, 2. The answer will be of this size. 8 is a group and it should be assigned to a certain element. Element should be assigned to this certain group, right? What should it be? Well, both 4 and 2 divides 8 without any remainder. but we need to choose the one with a smaller index. So 0, 1 is the index, then 0 index element is going to be assigned to group 8. Similarly, group 4, this should be 0. This should be -1. We don't have any element dividing 3. Yeah. And for 2, it should be 1 this time because 0 cannot divide 2 or 4 cannot divide 2. And finally, 0. Right? This should be the answer and this is the answer. So what we can do is we can try to use some sieve of Eratosthenes, if I'm not pronouncing it incorrectly. That technique can be used. We can have a range of numbers, and that range can be the number, the maximum value that we have in the group. That can be the range from 0 to max element of group, right? Groups. So this is the range, and we are going to traverse from the 0th element to all the other elements in the right order. And starting from 4, I'm going to mark all the multiples of 4, and then when I move to 2, I will only start marking till the point where I have not marked, right? I'll only mark those points, and same goes for all the other elements. And this way we can, eventually, after marking for all the elements in the range that we have decided, we start traversing for the group and start populating our answer array, right? So it's straightforward. We'll get the max element. Let me use a function for that. We can also iterate. This is basically iteration, but it's just abstracted. So groups dot begin, groups dot end. We have a vector. Sorry, this should be the range that we are deciding on. It should be from this to this. So let's call it factors index, and this will be of size max element plus 1, just for good luck. The default value should be -1. We will start from 0th element. We'll get the number. Let's get the number from elements of I. If the number, if for this number it is marked, which means previously I must have found a smaller multiple which has marked this particular number in the factors index map. In that case, I should continue. So if max element plus 1 is less than equal to num, first of all, it should be in range, or factors index of num is not equal to -1. In that case, it is marked. That means we can continue. We don't need to mark anything. Otherwise, we need to mark. From what point we need to mark? J is equal to num. From till what point? J less than max element plus 1. And we can only go through the multiples, right? At this point, if factors index of J is not equal to -1, in that case continue. Otherwise, mark this particular number with the current index, whatever the current index we are at in the elements array. So if we encounter something like 4, where J is 4, and we are at, we are at a multiple of 2, so it can be at 4, but we have already marked it for 4, which we have previously encountered, right? So in that case, it won't be -1. In that case, we shouldn't override it to the current index because we have already found a better index. And that's it. We got the factors index. Now we can easily traverse. We don't need to have an answer array. We can only, update the groups. Factors index. I'm sorry, factors index. Let's copy this. Add this particular index, or for this particular value, I must have already index inside the factors index table, which I'll get it like this, and eventually return groups. Right? Let's see if this works. Okay, spelling of elements was wrong. Max element. Alright, this should be this. Alright, this works. Let's submit it. Okay, it's taking a little bit of time. Alright, so the time complexity will be uh, for a particular element. This is, I can consider this amortized, but in worst case, it will be O of n plus m, if I'm not wrong. This will be O of m, and this will be O of n, but it's not exactly O of m or n, but it's amortized close to on average O of n. So that's the second problem of the contest. Third problem, count substrings divisible by last digit. So we're given a string S consisting of digits, and we need to return the number of substrings of S divisible by the non-zero last digit. Straightforward problem. We don't have any leading zeros in terms of what we need to do. It's straightforward. It's not so straightforward in the implementation. First of all, we have two approaches to this one. I'm going to use half DP, half tricks for the digits, but this can be solved using DP as well. So here, if we have something like this, what the question is asking is, at this point, ending with 1, whatever substrings we can form, that substrings are going to be just numbers, right? That's going to be a number. So if that number is divisible by 1, in that case, we are good. All the strings will be counted. All those substrings will be counted in my answer. Similarly for 2, 2 alone is a substring that's correct. 1, 2 together is also divisible by 2, and hence it's valid. It's going to contribute. 1 to 9 is not divisible. 2, 9 is not divisible, but 9 alone is divisible. Similarly, 1 to 9, 3 is divisible. 2, 9, 3 is not divisible, if I'm not wrong. 9, 3 is divisible, 3 is divisible, and so on and so forth. We get the idea. So what we can do for 1, if we have something like this, then for 1 we can say that anything and everything ending with ending with 1 is valid. So all subarrays are valid, right? Let me concise this down to are valid, and hence the number of contributions for this particular 1 will be, this will be at some index I, so that will be I plus 1. right? So if we have a 1 here, this index will be uh, here. The index is 2, and hence from point this ending with this, there are 3 subarrays. What are those 3 subarrays? This one, and this one. Straightforward 3 subarrays. We can get that from I plus 1, and that's what I did. Alright, now comes the part where 2. 2 is also the exact same thing. Anything and everything ending with 2 are valid, and hence let me copy this down. Similarly 3. For 3, let's wait a bit. For 4, let's see, we have multiples like 4 ending with 4. The next number will be uh, 24, and then 44, 64, 84, and so on and so forth. 104, right? 124, and so on and so forth. So we have 4. If we see that the ones that are ending with 4, the one previous value except the 4 alone is either 2, 4, 6, 8, right? 0, and so on and so forth. So if we look at the last one digit and we see if we are able to divide the total number, that is 24, 44, 64, 84, just 4, because 04 is just 4, 2, 4, then we see that it is divisible by 4. So it's a trick. It can be further proven, but for 4, we just need to just see the last or previous digit and check if together able to uh, divide. If yes, then I plus 1 again. Otherwise just 1, because 4 alone is also going to contribute, right? 5 is simple. Anything ending with 5 is going to contribute, so I can just copy this one. For 6, let's wait a bit. For 7, let's wait a bit. For 8, it's straightforward, and let's have 9 here. For 8, what's the trick? The trick is going to be exactly same as 4, just that we need to look for 2 digits instead of 1, right? So we have 8, we have something like 48, 88, uh, and so on and so forth. So we can just look at the uh, third, sorry, the one previous and the previous to previous digit and see if that is going to divide or be divisible by 8, right? So if we have something like 128 and then 168, and then these are all divisible by 8, we just need to check this. If we have something like 1000, and 1000 is also divisible by 8, if I'm, is that 1008 is divisible by 8? I think so. So if this is the case, then we just need to check this 3 digits and see if the number that's going to be formed, if it's divisible by 8 or not. Just that, just similar to the fourth one, we are going to do the same here. So let's copy this, previous and previous to previous. Check if together able to divide. If yes, then we need to do I plus 1. Otherwise, we need to check So here's is something like check previous and previous to previous, or if previous to previous is not working, just previous should be working. So if something like six, not 16, uh, 48, yeah, 48. So we don't have a third digit, but still we can have at least two, right? So check just previous and see together if we are able to uh, divide it by 8, and that's going to be contributing I plus 1, or just I, actually either I plus 1 or just 2 or just 1, right? Something like this. So if we have a third digit, then it's going to be either I plus 1, or it's going to be just 2, or it's just going to be 1. 1 why? Because we have at least 8 as a digit alone. So for 3, 6 and 9, what I can do is I can use the remainder, a running remainder for every digit, right? So I can have a map that I can call 9 map, 9 mod map, and this is going to contain 0, 1, 2, 3, 4, 5, 6, 7, 8. These are all the remainders that I can have for 9, right? So for every number that I see, I am going to take the remainder of that number and update my map based on the previous remainders, right? So this can be a little tricky. I'll explain it a little uh, using the code itself, right? I'm going to do the same for, I'm going to do the same or use the same map for 6 and 3, and for 7 I'm going to have a 7 map as well. This mod map technique is going to be usable for all the numbers, but since we have tricks, that's going to optimize further than using the map, but still the time complexity is not going to differ a lot. It's going to be just a little bit slower. Let's have a map. As I said, we are going to have a vector. Let me call it 9 mod map. This is of size 9. This is of size 7. We are going to have an answer for every number that we see, and we straight away start iterating through the S string. Let's get the digit first in integer form because it's a character. Here, first of all, uh, no matter what number it is, we need to update the 9 and 7 mod map, right? So let's have, since we are going to update the mod in a running fashion, and I am going to do that for both 9 and 7. I'm going to create a common function that I can reuse for both. I'm going to pass digit 9 mod map with the divisor to know which mod map I'm operating on. So it's going to be 9. This is the divisor. Similarly 7. If I did update the mod, then I'm going to check if the digit is equal to 1, or digit is equal to 2, or digit is equal to 5. If any of this case is there, Then I'm going to update the answer plus equal to I plus 1. Like I said, we have anything and everything valid till this point. So I plus 1 is the contribution to the answer. If the digit is equal to 3, or let's do it for 4 first. In that case, we are going to check the one previous digit if it is there, otherwise we are going to add 1, right? So we are going to check if we can just straight away add 1 at least, right? Because 4 alone forms a digit. Then we can check if I minus 1 is greater than equal to 0. We have any previous digit to be checking, right? To check. Then we are going to form Si minus 1 minus 0 as a digit and multiply it with 10, right? This is the previous digit, so its order of magnitude will be 10th, right? It's at the 10th place as of now with respect to the current digit, and we are going to add the current digit, that's 4. We want the remainder to see if it's divisible by 4 or not, so we are going to mod it with 4, and let's have a condition operator here, that's AND. If it is equal to 0, then answer plus equal to what? It shouldn't be I plus 1 this time, because that plus 1 was coming from the digit alone, right? But since we already did the answer plus plus, we should only do a I here instead of I plus 1, right? And similarly, let's check if the digit is equal to 8. Then we can just straight away do a answer plus plus first. Then check if I minus 1 is greater than equal to 0. If we have a previous digit to check, then we are going to check that in a similar fashion. So let's copy this and update it for 8. Or you know what, let me just do it this way. This is common, this is common. If I minus 2 is also present, that means we have a further another digit to be checked. In that case, let's have s of I minus 2. Let me just copy this down and just add one more. That will be s of I minus 2 minus 0 into 100 this time, because this is the 100th place. Alright, and we are good with this one. So if this is true, then we are going to add what to the answer? Just 1, isn't it? Because just if we have something like 48, 48, in that case 8 alone has contributed. Oh my bad, I did some mistake. This is another digit, right? This is the previous digit. So if we have 48, then 8 alone is already contributed. 4 is the only thing that needs to be contributing here. So it should be answer plus plus. But at this point, it's going to be anything like 100,008. I hope this is divisible by 8. Then this is going to be divisible by 8, right? And hence, I'm going to come here, but I'm going to take the entire number now because it's going to be valid. So answer plus equal to I minus 1. This time I minus 1. Why? Because we are taking this much portion and adding to our answer, because these two are already added here, right? Because if this is true, if this is true, then this is obviously would have true, would have been true, right? Or I can just do a else if here as well. But in any case, let's move forward and do the more interesting one for 3 and 6. We need to do something here. If digit is 7, then we need to do something here. If digit is 9, then we need to do something here. So let's create the update mod map function here, and then let's see how it's going to work. So let's have a void update mod map. First thing is we are going to get a digit, the vector. Let's have a reference because we are going to update this in a running fashion. So this is going to be updated with a new mod map, and let's create a new mod map which is going to use the previous mod map values. So this is going to be of size divisor. The first thing we are going to update in this mod map is the digit itself, right? That digit itself with the divisor is going to give me certain remainder which needs to be updated in the map, in this new updated map. Let me call this remainder map, 9 remainder map. By the way, this is 7, so let me update it. I forgot to update this. So this is 9 mod map, 9 remainder map, 7 remainder map, right? And this is new remainder map. And I'm going to update the new remainder map at what time, at what point we need to update. We need to update digit mod divisor, which is either 9 or 7. Divisor is either 9 or 7. I'm going to update it to 1 because see 2, if we are at 2 or if we are at 1, then we see that 1 mod 9 or 1 mod divisor is going to give me something that needs to be updated here, right? And that's it. That remainder space is going to be updated to 1, and for every remainder, or let me call this instead g of I, let me call this remainder less than divisor remainder plus plus. I just went till divisor because further we can't go, right? We can't have 9 as a remainder when divisor is also 9, right? We can only have from 0 to 8 as a remainder. So that's why if I don't have any, let me call this remainder map. This is previous remainder map. Previous remainder map. If previous remainder map of this remainder is not equal to 0, only then we need to do something, because otherwise I don't have anything to carry forward, right? So this new remainder map is going to be updated at what point? It will be updated. So this is the previous remainders. I can even call this previous remainder, but let it be remainder. So previous remainder into 10, because the previous digit would be 10, plus the current digit, which will be digit. I want the remainder. I want the remainder when divided by divisor. So that will be provided using mod divisor, and this will be accumulated from the previous remainder. So this is going to be accumulated here, and this way I'm going to update my previous rem map with the new rem map and return. I'll also print it to show what's happening here. Finally, digit equal to 7, digit equal to 9. What's going to be the answer here? Well, that can be calculated or looked up from the remainder map when a digit will be divisible by 7. It will be divisible by 7 when the remainder will be 0. So I'm already having the number of arrays that is against the 0th remainder here, right? So I can just add answer plus equal to from the 7 remainder map, add the 0 1, right? These are all the values that I have, and that is contributing to our answer. Similarly, I can have the same exact thing here, but this time will be from the 9 remainder map instead of 7. For digit 3 and 6, what we are going to have is uh, so let me just give a brief about this. So 3, 33, 63, and 93, and so on and so forth. So any previous remainder that we see, right, that will be there inside the 9 remainder map at this point. We can look up and see for any remainder. Suppose we have a 3 as a remainder, if we have a 6 as a remainder, if we have 9 as a remainder, we can't have 9 as a remainder. If you remember, it will be 0. It will be represented as 0 inside the 9 remainder map. So I can consider this as 0 instead, but let it be 9 as of now. So if we have 3 as a remainder, 6 as a remainder, 0 as a remainder, I can take all of that, multiply it by 10, add 3 to it, and it will still be divisible by 3, right? So I can use 3, 6, or 0 as the remainders for digit 3 and 6. So I can use all of those contributions for my answer. Same goes for 6 as well, right? So 6 as well. 6, I think 36 and 66, 96, and so on and so forth, right? So we can just add to our answer from the 9 remainder map, the remainder, uh, the key remainders should be 0, 3, and 6. That's it. All these will be contributing to our answer for either digit being 3 or 6, right? So let's see if this works. Okay, there should be a semicolon. I need to return the answer. Okay, this works. Let me also, just for the sake of it, uh, yeah, let me print this one. I'll just print it for divisor if it is 9, so that it's not messy. So let me print it like this. We will see how it's how the remainders are jumping. Right. So if we have for 1, the remainder is going to be 1, right? 9 mod uh, 1 mod 9 will be 1. This will be the first one. 1 mod 9 will be 1. All the previous remainder maps will be 0. So it's never going to enter this and it's going to print. And this is the printed version. For 2, what's going to be the case? For 2, it's going to be 0 into 10 plus 2, right? 0 into 10 plus 2. And since we have no previous remainder maps, it's not going to move forward. But this 1 is going to move forward, right? This 1 was from the previous remainder. So it's going to move forward how? 1 into 10 plus 2, that's 12. We are here. Previous remainder was 1. 1 into 10 plus 2, that's 12. Mod 9, because we are doing it for 9, is going to give me 3. So this is going to jump to 3 here, and 2 in itself is going to give me a remainder, right? 2 mod 9 will be 1. So here, so that's how it's jumping, and that's how we are getting the answer. So let's submit it and see if this works. It does, and that's the problem. So it's going to be O of n operation, O of n in terms of time complexity, and space is constant, close to constant, right? That's the third problem. Thanks.